Okay. Lecture 12, Dalton's atomic theory. These are terms you should know the definitions of. What are the four postulates of Dalton's atomic theory? Well, we have matter is made of atoms. So this is going to be a very, it's going to be abbreviated. You can really keep it a minimum of words just to cover the idea. So, 2, an element is made of one type of atom. Now, matter is made up of atoms. We know that the atoms are then made up of 3 subatomic particles, and those are made up of other subatomic particles. But Dalton didn't know that. And so it's basically true. For the stable matter that we normally deal with, it's made up of stable atoms. An element is made up of one type of atom. We know that there are isotopes. Again, Dalton didn't know that. But basically, these postulates are true. A compound is made of 2 or more types of atom. And that's pretty much true. Nothing wrong with that idea. And then a chemical reaction is a rearrangement of atoms. We don't create them or destroy them. We just rearrange them during a chemical reaction. So those are the basic ideas. What does the law of multiple proportions tell us? Well, if we have 2 compounds made up of the same 2 elements, it can be more than 2, but we'll just deal with 2 here. So it's 1 to 1 and 1 to 2. That their masses will be in ratios of small integers. So if we have 1 gram of carbon, so we take carbon monoxide, we break it down, we have 1 gram of carbon, then we'll find that we have 1.3321 grams of oxygen. And if we have CO2, 1 gram of CO2 will, if we break it down to its elements, we'll have 1 gram carbon and oxygen. 1 gram of carbon will also, for CO2, will also have 2.6642 grams of oxygen. You can see that these are equal, and then the relationship between 1.3321 and 2.6642, well, 2 times that gives us the same number. So we can see that the ratios are always, as they say, small whole numbers or integers. So, and why that was, because of that, they could then hypothesize that there were atoms, and the different types of atoms had different masses, and they were right. And that's why the law of multiple proportions is so important. Before they knew that there were atoms, they could still deal with, distinguish between compounds by their relative masses of the elements once they had broken them down. Now the next part here is going to be covering the symbols and names of the first 92 elements. You need to know those. If we're going to do anything in chemistry, you need to know the names and symbols of these elements. So let's go through them quickly. So a nice little quiz for you. The symbol for, and if you come into this class, if you've had any chemistry before, you should know at least half of them, right off the top of your head. And then with a little work, get the rest of them. So symbol for hydrogen is capital H. It's not this. That's not... that's Planck's constant. That's not hydrogen. Has to be capital. Symbol for helium is capital H, lowercase e. It's not this. That's he. That's a pronoun. It's not this. Not sure what that is. And it's not, definitely not that. These are all mistakes you make. And going to lowercase letters on the internet and by texting, that's becoming very common. But when you're dealing with scientific terms like this, these symbols, they have to be put in the proper form. It has to be uppercase for the first letter, lowercase for the second. If we don't do that, then we have trouble distinguishing. As soon as you see this in that form, just standing alone, that has to be helium. So at the start of a sentence might be a pronoun. But for lithium, Li. You see capital L, little I, that is definitely lithium. Beryllium, Be. Boron, on here, is capital B. Now, here we fill in the name. Carbon, C is carbon. And then capital N is nitrogen. No need to capitalize carbon or nitrogen, unless it's at the start of a sentence. For the name, though, it's going to be lowercase letter to start out the name. Okay. We're going to go through all 92, either the symbol or the name. Symbol for O is, so this is oxygen. I'm going to go quickly. Fluorine, don't forget the U. See that, where people miss that U all the time. Neon for Ne. And then we have sodium, which is capital N-A-M-G-A-L-S-I-P. Okay. Then we have sulfur. Oops. Chlorine. AR is argon. K is potassium. Potassium one time was used the term kalium. In a lot of countries it's still kalium, K-A-L-I-U-M, but we call it potassium. This is calcium. And then we have SC for scandium, TI for titanium. Okay, keep going. And I just pause to make sure it's on screen here. So if it's not on screen initially, I'll scoot it up. Vanadium, V, Cr, Mn, Fe, Coni, Cuzn. Then we have Ga, gallium. Ge is germanium. Arsenic, selenium, bromine, and then we have Kr, Rb, and Sr. Hopefully you're using this as a little quiz and trying to stay ahead of what I'm doing here as I put them up, pausing, to see how many that you can get off the top of your head. Yttrium is, make sure it's on there, Y, zirconium, Zr, and of course I'm not saying capital and lowercase all the time, but it just has to be in that form. I'll just say the letter. Now we have Nb, niobium, Mo, molybdenum, Tc is technetium. It's not technetium, as I thought when I was a student, and I pronounced it that way for years before someone mentioned, yeah, it's technetium. So I'd like to say these out as well for you. Ruthenium, rhodium. Then we have palladium, Pd, silver's Ag, cadmium, Cd, indium, In, tin is Sn. So make sure that you have that correct, written correctly. Stannous is where the term that that Sn comes from. Sb is antimony or antimony. Seen that a lot lately, but I usually pronounce it antimony. Tellurium and iodine. All right, what do we have? Xenon. Cs, this is cesium. Ba for barium. La for lanthanum. And then we have cerium, is Ce. Praseodymium is Pr. And these P ones can get a little tricky because there's a lot of them. Neodymium is Nd. Now, then the symbol for, okay, for some reason I've repeated this. There's a lot of cutting and pasting, so I didn't have to write these terms over again, but symbol is, this is neodymium. Symbol, so now this is a new one, promethium. Then we have samarium. And then europium. Then we have gadolinium, Gd, terbium, Tb, dysprosium is Dy, holmium, Ho. Okay. Then we have erbium, it's ER. Thulium is TM. Ytterbium is YB. Lutetium is LU. Hafnium HF. Tantalum TA. Then we have W is Wolfram, now we call it tungsten. RE, this is Rhenium. And you can see that we have to go with RE because RH is already for rhodium earlier. So that's what they generally do. If you have two elements with the same first letter, we go to the second letter. If they're the same second letter, we go on until we find one that's different. So whichever one is discovered first usually gets the earlier letter. Then we have iridium, so osmium, iridium. Then we have platinum. Gold is AU, HG, then thallium is TL, and then lead is PB, not PD. This is wrong. I pointed out because people they see lead and they see that D and they know there's a P involved, they know it's different, and they say PD, so no, 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 PB. Make sure it's on there. Alright, coming up on the end here. Bi for bismuth. Then polonium. Discovered in Poland, so it was polonium. Astatine is the rarest naturally occurring element. Only believed to be only a few grams of it in the entire Earth's crust. Radon. Rn is radon. Then francium. Radium. We'll come back to this in a second. Actinium is AC, and then thorium is TH. When you look at radon and radium, they're so close, they sound a lot alike. They both have RAD. How I remember it is radon gas is the deadly gas that comes out of the basements. That's one of the things that you check for. If you get radon poison, you'll need an RN. You'll need a registered nurse. That's how I remember it. And that's the deal.